first step here is if we're differentiating or integrating, we would rewrite the radical. So I always start off by doing that, is rewriting any radical that I have. So in this case, I would rewrite the denominator as x squared plus 1 to the 1/2 power dx. All right, now once you do that rewrite step, you then see that you have a quantity in parentheses. And anytime we have this quantity in parentheses, that is our indication that we want to use u substitution. So when we see the parentheses, we think about our u substitution, and our u will be defined as what is in parentheses. And that's a good starting point. Again, we might have to play around with it to get it to work out, but we start with thinking about the parentheses quantity for our u. Now, du, take the derivative. So remember, derivative, you drop stuff. So you drop down this 2, so it becomes 2x. The plus 1 is going to drop to 0, standalone constant. And then we have our dx. All right, so I like to do this substitution of u and du as 2 separate steps. So I start off with like the most obvious thing, which is our u is x squared plus 1. That is going to get replaced. So I will have in the denominator now, this x squared plus 1 will be u to the 1/2 power. Now, that will leave us with x and dx. Okay, and again, this is our little intermediate step to get it all changed around. So we need to have, for our du step, we need to have 2x dx. So we have the x, we have the dx, we need the 2. So we will multiply in by a 2. And when we multiply in by a 2, we've changed the integral. So that means that we'll have to divide by 2 to balance things out. Now, what that buys for us is this 2x dx that is defined as du. So in the numerator, all this 2x dx, that's becoming du over u to the 1/2 power. And then I still have the integral, and I have the 1/2 power here, or 1/2 coefficient, okay? Now, at this point, everything is in terms of u. So we have successfully switched this to u. So once we have switched to u, then we go to our next step, which is where we integrate it. Now, if you think about taking the derivative of this function, you would be bringing the u to the 1/2 up into the numerator. So that is going to be the same step that we're going to do for integration. So we're first going to simplify first, and then integrate. So I'm going to bring this u to the 1/2 up, and then now I'm in the position to use my power rule, where with integrals, remember, we add, so we're going to add 1 to the exponent. So negative 1/2 plus 1, we get 2 over 2. So we're going to add 1/2, and then divide by the new exponent. And then we add the plus c. Now, that is just the integral for u to the negative 1/2. We still have this 1/2 constant that comes along and tags along. All right, so we've talked about this a little bit before, but anytime you have this fraction in the denominator, so this denominator fraction, you are always going to flip it. So if I flip that denominator fraction, that is going to become 2 over 1, and then I will have my u to the 1/2 plus c, and this 1/2 will tag along. So you see by flipping that these 2's cancel out, and you're left with u to the 1/2 plus c. So now we are finished with our integration step and simplification. So now our last step is we switch back. So we switch back to the original variable, and the way we do that is using the fact that u is equal to x squared plus 1. So we will plug in for this u the x squared plus 1. So this is going to become x squared plus 1 to the 1/2 power plus c. And that is our final answer. Do keep in mind, if you wanted to, the 1/2 power, of course, could be rewritten as a square root of x squared plus 1 plus c. But either of these answers are perfectly appropriate.